But I wanted to tell you about kind of what is the main problem here. What is the thing that artificial intelligence can solve? So one thing you might be familiar with is a movie recommendation system. So like Netflix, what Netflix does is it has a lot of information about what people rate different movies. And then based on that data, they can make predictions about what movie you're going to want to see. So I wanted to kind of bring this to some math that you're actually used to and that you've seen before. So let's say we wanted to make a movie recommendation system. And we have a bunch of data. What is this data? Maybe we have two different movies. Maybe we have Star Wars Episode 1 and Star Wars Episode 2. So you have your X variable, which is going to represent your rating for Star Wars Episode 1, your Y variable, which is going to represent your rating for Star Wars Episode 2. Each one of these dots is a person, right? And you put the dot where you've rated Star Wars Episode 1 versus Episode 2. And it makes sense that there's some kind of correlation here, right? People who rate one of those higher is going to have a higher rating for the other one, most likely. And so you can use that information, that correlation, to form a basis for a prediction as to what someone else is going to want to see. So how does that work? Well, you've seen this in a science class probably, where you have a best fit line through your data. This is something called linear regression. But it's just a fancy term for the best fit line. And what that lets us do is it lets us make a prediction so that if you know what the rating is for some new person, you can guess what their rating is going to be for the next movie. Right, so that's the idea. So just for some terminology here, as a lot of you have taken algebra or beyond that. So the equation for a line is going to look something like this, y equals mx plus b. And what that means is when you have a rating of x, you're plugging it into this equation to figure out what your rating for y is going to be. And the m and the b are, for the adults in the room who may have forgotten, the slope and the intercept of our line. But it doesn't matter what they actually mean. They are what we call parameters. And by adjusting those parameters, we adjust where the line is. So that we adjust the slope of the line, and we adjust the intercept, which is how high up it is. So another way to look at this, and just to use the terminology of what's called machine learning, which has become synonymous with artificial intelligence, is we have this data. It's our training data. And then we want to train our model. Our model is this line. And when we say we want to train the model, we're actually selecting our best parameters. So we're just figuring out what are our best parameters here to make our best model. So that's what we mean by train a model. After you train your model, then you can make predictions. And it's the same in linear regression as it is in machine learning. It's just a lot more complicated. So with this one, we have one variable for our input, one variable for our output. We could expand on this. We could imagine going into maybe having two variables for input, x1 and x2, and we have our output as y. We still have our data. But maybe now instead of a best fit line, we have a best fit plane. And that tells us how to make our predictions based on, say, our ratings for episode 1 and 2, what our episode 3 rating might be. And we could expand upon that too. We don't need to stop at 2 dimensions. So I have some students from multivariable calculus here. We know we can go to multiple dimensions. We can go to as many dimensions as we want. So that's one way to expand, is going to multiple dimensions. Another way we could expand this is by making a more complicated function. So maybe a more complicated function. Instead of a plane, it looks like some kind of surface, something weird. But the point is, we can add more parameters and we can make our function more complicated. But the procedure is always going to be the same. We're going to have some data. We're going to use that data to train our model, and then we can make predictions based on that model. All right, so let's move on from there. So what are some examples of what you can do with that? So this is just a summary of what I was just talking about. One easy thing you could do with this is, say, distinguish between the photo of a cat and a photo of a dog. So what you would do for that is you would have a bunch of data. You'd have a bunch of photos of a cat, you have a bunch of photos of a dog, and you label them, whether they're a cat or a dog. That's your output, is your labeling. And then you train your model. So it's going to be some complicated function, but what you're doing is you're adjusting parameters. Once you've found those parameters, so once you've done this training, then you can give it a new photo, and it can detect whether it's a cat or a dog. So that's the basic idea there. So there have been a lot of applications of this sort of thing. You've seen movie recommendations for Netflix, Amazon, music recommendations from Spotify. That same technology can be used for targeted ads, right? So they're using the same kind of recommendation system to think about what else would you want to buy based on what else you've bought in the past, or what they know that what you like to do, that sort of thing. So Google is very good at that. But then you might have also read about, with these recommendation systems, that there's a push toward kind of more extreme content. And generally people will tend to click on things that are more extreme beyond what they would normally, and that can be a problem. So these recommendation systems, while we like them, there's some great things about them, there's also a lot of issues that we've seen in the past few years that have cropped up because of these systems. Another big application of artificial intelligence is facial recognition. And you've probably seen this in social media posts where your friends are automatically tagged with their faces. That's a great use of it. Another great use is when you have some large-scale insurrection and you have a lot of people that are out in public and you need to know who they are. So this was used in the Capitol riots. It was actually there were citizens that used this technology and figured out the identity of people who were involved in the riots. On the other hand, there are problems, right? So there's problems with people who have been wrongfully arrested for things because they were misidentified by a face identification. There was a teenager not too long ago that was denied entry into a roller rink because she was misidentified as someone else who had caused a problem at that roller rink previously. There was a guy who was arrested from an Apple store because he was completely misidentified. He was just a customer, but he was somehow misidentified with someone who had shoplifted, and then so he was arrested. So there's a lot of possible issues with this kind of identification, especially when the technology is not perfect. So the photo, oh, I'm not seeing that. Oh, I'm sorry. That is what I wanted to be showing you. 1 second. I'm having a technology issue. There we go. Sorry, I thought I was showing you that, but that's okay. We're on this one. These photos on the bottom, that's a researcher named Joy Buolamwini. She's at the MIT Media Lab, and she's done some great research on how good this technology is, how good this face recognition technology is. And she got into this research because she noticed that this face recognition technology was not recognizing her own face until she put this white mask on. And so she did a lot of great research into the public companies that had been putting out this face recognition technology. And you can see that research still. There's a great documentary that she put out called Coded Bias. There's also been some concern about law enforcement using face recognition technologies, also just for things like surveilling people who are gathering lawfully. So there's been a reaction to that, including a number of cities that have put out ordinances to prevent police from using facial recognition technology. Police departments are finding ways to get around this. So there's some continuing issues with that with law enforcement. So as you can see, what artificial intelligence is really good at is recognizing patterns. And so I wanted to just talk about some of these other applications that you might know or might not know about. Things that we use all the time. So that first one, optical character recognition, that's handwriting recognition. The US Post Office has been using this for years now to be able to direct messages to where they're supposed to go. But your spam filters for your email, fraud detection for credit cards. So if someone steals your credit card and goes on a buying spree, your credit card company usually knows right away because they can detect the pattern. And that's because they've been training their AI on these patterns of people buying for years and years now. It's being used for cancer detection now. There's some research from Google image recognition where they were able to identify cancers better than radiologists were, expert radiologists at identifying cancers in certain lung cancers. It's also being used in all sorts of other sciences. So if you're interested in astronomy at all, one of the big things in astronomy is the detection of exoplanets, so planets that are in other solar systems. And you detect that by looking at the data and kind of filtering through lots and lots of data. It helps if you have machines that that can search for patterns like that. So on the other side, we're also using this for things like approval for loans, insurance rates. If you apply for a job somewhere, a lot of times your resume is being filtered through some kind of system first before you even get a chance before it gets looked at by a person. So you can see that could cause some problems if you don't have the right keywords in your resume, or if you're born in the wrong zip code. We've had a lot of research into an area called predictive policing. So predictive policing is the idea where you can look at your historical patterns of criminal behavior and then graph all that on a map, and then you have your hotspots, and that's where you direct your police to have a greater presence. And so you can see why that might be a problem with this kind of machine learning. So how this machine learning works is you train your model based on your data, and then you make your predictions based on the patterns you saw in your historical data. So for something like predictive policing, you're going to end up sending police to the same places where they've been sent before. You're only going to be perpetuating these same kind of patterns that you've seen historically. I saw a disturbing story recently on automatic target acquisition that was being used by the Air Force. So they have lots of satellite photos of potential targets that they might want to hit. So for the first time, they used this in what they called their kill chain, which meant that it went from their intelligence through their gathering, through the software to filter it, and that was what their actual target became. So you can see that there's some potential issues with that kind of application. Here's a couple other things. So a lot of our advances have come through the practicing with games, so things like chess and Go. That photo on the left there is Garry Kasparov in the 90s when he was first defeated by Deep Blue, which was the IBM artificial intelligence that was designed to play chess to beat him. That was kind of a turning point in AI when we could see when it could actually beat a human chess player. Soon after that, I guess more recently, we've been able to beat Go, which is another game that's actually harder to simulate. AI has been used for actually playing video games and for playing things like flight simulators. Recently, an AI was able to beat an actual F-16 fighter pilot in a virtual dogfight, which is another kind of scary application of a good AI. One thing we've heard a lot about is self-driving cars. There are a lot of, and then you can see over there the photo next to it is that is a photo of a robot dog with a gun on it, which someone actually built. That's an actual photo of something someone actually built. So you've seen these photos of robot dogs. So you can imagine the problem with having something like this with a gun on it with an automatic targeting system and automatic target acquisition. So you can see some potential dangers there. But even if we aren't talking about robot dogs, just with self-driving cars, there are a lot of ethical issues that we might be thinking about. So here's an example with a self-driving car. Let's say you're stopped at a red light, and your car determines that there's a truck that's coming toward you, and if it moves you out during that red light, then you'll be saved. So should it break the law and move you through that red light? What if there's someone in the crosswalk? What if there's 50 people in the crosswalk? What if you're in a luxury car and you expect that, well, because I paid $50,000 extra, you should prioritize my life over those poor people in the crosswalk? So there's a lot of ethical issues involved with self-driving cars and what can happen with those, how we should regulate them. Mainly, I guess what I want to leave you with is that AI is advancing really quickly. We can do a lot of really cool stuff with it, but it's not a good or a bad thing necessarily, right? We can use it for good or for bad. What it is good at is detecting patterns and making predictions based on those historical patterns. And so what's really important is that our future leaders, which is you guys, that you understand what the advantages and disadvantages are of this technology. All right, so that's what I wanted to tell you about. But I also wanted to remind you about the coding workshop on Wednesday. And do you guys have any questions? No? All good? All right, well, thank you all.